To everyone, Raja is a member of the Rhino 3D development team at McNeil and Associates, and she's based in San Diego. So this is where she is zooming in from right now. She doesn't only have the master degree from the School of Architecture and Planning, but also has a master degree in computer science and engineering from University of Texas. And yeah, over the past decades, she has been presenting at various conferences, at running various workshops, teaching at various universities. So she's extremely experienced, and now we are at the source of those people who are actually developing Rhino, which I think is the favorite modeling tool at the school. And yeah, once again, we are really super grateful for this.
Yeah, thank you very much. I really appreciate the introduction. When did we get together, Yuvi? That was a few months ago, but it feels like it's been for ages, you know, at Acadia, right?
At Acadia in Texas, at Austin, yeah.
Yeah, in October. So it's amazing, you know, these days. It's kind of difficult, but at the same time, we're feeling like we're connecting with people more because everybody is Zooming, trying to do something with their lives. And it's been a wonderful opportunity to reconnect with everyone, and really great pleasure to be able to, you know, take some time out of my schedule and be able to devote it to you know, be with you guys. And thank you very much for your interest and, you know, for the time and all that. I hope it's going to be fun. And I don't know if you got my my email, you know. I'm mostly, you know, a developer, so I'm a programmer. That's, you know, what I do is my day job is writing code and programming. And obviously we do use Rhino, and but you know, I'm not like proficient modeler. I probably know more under the hood than, you know, the modeling workflows. But one of the things I noticed that most of our material developed within McNeil is not, you know, directed towards architects, although it's applicable. So I kind of took on the project of trying to adapt it and make it more, you know, relatable to architecture. So that's kind of how the whole project started. And you know, I shared the a Google Doc with you guys, which is the first part. I have 3 parts in the manual, but I thought I share one part at a time so we don't go ahead of ourselves. And we try to go through it and see if it makes sense to you guys as a way to learn Rhino. So we will loosely follow the manual, just so that, you know, we can go back and revisit certain topics and we don't get overboard. And also, you know, at all times, this is very interactive, very casual. We all kind of here together in it, and you know, I want it to be you know, interactive experience, and you can jump in, you can ask questions, you can say this is not working, this can be done differently, and you know, you can do a research, shoot me email anytime. It's going to be like an open discussion for the coming few weeks. And you know, my interest is to be able to test the material and see if the flow makes sense and adjust it, you know, as you guys use it and as I teach it. And you know, I found that to be quite effective way to be able to produce meaningful material to people. So your input will be extremely appreciated. So I guess, you know, we'll try by the end of the course to create that that building. And basically it the reason why I did it, it has both the rectilinear kind of modeling, but also the freeform modeling. And this way we can go over as much of the Rhino capabilities, modeling capabilities as possible. So we're gonna start doing the modeling starting next class, and we will go through the steps together until we produce something like that. And that should help us go through like the basics of modeling, but also some of the advanced features, you know, in relation to modeling. Of course, Rhino has a wide range of functionality other than modeling, but I don't think time will allow to go and expand on different ways of modeling using, say, for example, Grasshopper or plugins and all that different other things, which, you know, is very important in Rhino, because we treat Rhino like a geometry engine or modeling core, and its strength that it doesn't really get engaged in too much functionality beyond the core, which is very stable and very powerful. And we rely on third-party developers to write their own plugins to help more specialized workflows. So if you're using it for robotics, or you're using it for VR, or you're using it for you know, specific you know, animations, or very advanced rendering, or you know, prototyping, or what have you, or jewelry, or marine design, you know, there are hundreds, if not, you know, more of very reliable plugins, you know. So this is really the kind of structure that Rhino relies on, and this way it can get away with being, you know, a very small group of developers, and we can stay like you know, on top of things, and we're agile, and we can change and add things this way, and support a community of, you know, wide community of users. So that's the kind of general philosophy behind, you know, Rhino development. What we will do is I provide that manual, which or the handout. Eventually, it's going to be about 100-page manual, and the idea is that you know, we're going to go through the concepts, as I said, loosely, but you will have a reference where you can go back and be able to read it through and follow very carefully. I'll show you where to find the information, but I'll draw your attention also to things like these areas, these boxes, where you can actually go and watch a video done by one of the Rhino team about that specific topic. Right? So you will have plenty opportunity to go back and revisit the concept at your own pace and be able to see some of these videos. And if there are missing videos and additional concepts that we need to kind of create videos for, we can also create videos for those. That's part of my effort as well. And if you find really awesome videos about certain topics that I haven't linked to, please, you know, feel free to go and say, oh, in relation to commands, you know, I found so-and-so video. Just feel free to add a comment and say, you know, hey, I found this video, this good tutorial, you know, and link to it, you know. So feel free to, this is a living document. You can use it as a discussion platform as well. And if there are things that are not very clear and, you know, confusing, just comment it so I can go and revisit and be able to improve the document so you guys, you know, find it really useful and rich and, you know, serve the purpose of learning Rhino. Does that sound like, you know, a plan?
Yep.
All right.
Yep, very good.
Great. So so even if you feel like we're going through things fast and you're kind of hard to keep up, always you can go back and go back to the document. And you know, just because I'm using this camera, I lost my sketchpad. So I was hoping I can sketch a few things with you, you know, on a whiteboard, but I think we're gonna have to kind of let go of that part, and you know, I'll just try to communicate verbally with you, you know, with what we need to discuss, and yeah. Any questions about the format? I guess the one last thing is, once we open Rhino, feel free to follow along with me. Uh, I'll try to be kind of slow. If I'm going too fast, always let me know. But also we will have like a short tutorials, like 20 minutes and then 10 minutes discussion sort of kind of format. So we allow more interactivity. So we can have a bit of a flow when we do stuff. And then after that, we can, you know, discuss and revisit and re-explain certain things. This way, the 20 minutes can be more like, if it's recorded, it's easy to kind of. Somebody logged in with a mic maybe open through the computer. Yeah, I think they muted. Thank you very much. I was hearing myself, you know, like an echo. So yeah, this way we try to get things done in one flow, and then we can have time to kind of redo and discuss things as well. So this way we can keep things running within time. How does that sound? All right. So yeah, let's get right to it. So you know, right now there is the Rhino whip, which is Rhino 7. And it's been in development for a few years now. As you know, if you own Rhino 6, you can directly access, you know, Rhino 7 web. And, you know, we anticipate that it might be released, but it doesn't matter when it's going to be released. You already have access to it. It has awesome new features, but we will not use that. I know you guys have Rhino 6, and, you know, when you open Rhino 6, this is basically what you see to start with. Here, I'm gonna move that picture. Is that better? Now you don't see people, right? So you see the workspace a bit more. For those of you who are familiar with Rhino, you're pretty much comfortable with the working environment, which is what you see immediately when you open Rhino. But before I get to you know, the nitty-gritty details of, you know, how to handle the workspace and what to do and all the modeling parts, I just wanted to kind of take a step back and say, you know, let's just put things in context. So I always like to challenge the idea of design and modeling, especially when using software. And if you dig my thesis at Auckland University, you'll see I tried to kind of critically analyze available software or applications at the time and try to understand their shortcomings. And that really what motivated me to go and you know, become actually more of a tool maker than an architect, because I felt that not many designers are involved in the development of design software, and that was 20-something years ago. And since then, I've been actively involved and have been with McNeil for many years, and you know, the better part of 2 decades. And we've done a great work at the time and brought in a great community. So that critical mindset is what I want to communicate with you guys, and I hope it comes through because it will help you control your environment rather than the environment start to control you. In a nutshell, 3D modeling is basically the process of using computers to synthesize and reflect on design ideas, and then communicate and share with others. And it has to serve that purpose for you. Otherwise, you know, it's doing you disservice, really. And for computers and computer graphics, they use geometry as the primary conduit to represent design ideas. And, you know, so, you know, I'll just create something real quick. I know I'll go back and explain the interface, but I'm creating now a box, and now I created something, and I'm reflecting on it. And, you know, I just want to change, you know, the proportion, or, you know, change the form of it. Or so I'm kind of starting to kind of reflect on my form, and I'm trying to understand what I created. And now, you know, I didn't create it with specific distances. I'm just trying to measure. This is like a 13-meter height, and you know, I want to view it in a few different ways. And you know, when I share it with someone, I need, you know, to print it out, sketch on top of it. You know, I want to create certain kind of field to it to investigate and interrogate my form. And you know, Rhino is really good at, you know, the ability to quickly synthesize form, reflect on it, adjust it, reformat it, and be able to share it with, you know, a tremendous number of formats. So if you go save as, and this drop-down menu, and you don't have to follow with me at this point. I'm just trying to kind of give you a general kind of feel to the environment. There are so many file formats. Actually, one of the main purposes people started using Rhino many years ago is because of its ability to export to variety of file formats. And Rhino file format is open source, and any program, any 3D program, any CAD can read and write to Rhino using open NURBS, and at no cost on their end. So so that's, you know, the Rhino and Rhino developers are big believers of, you know, building community, collaborating, and open source, you know, to be able to freely use the kind of application that is most suited to your need. And this is why, you know, much of Rhino is an open source, and it's accessible in so many different ways. And it's extendable as well. And this is why we have a community of developers and plugin developers that write on top of Rhino. One of the strengths of Rhino is that, you know, it uses NURBS modeling. So let me delete that. And what I mean by that is the ability to create freeform curves and surfaces, and be able to interactively you know, modify those. And also the ability to very accurately represent surfaces. And those surfaces basically can be printed out or exported at a very small, you know, tolerances. And this is why Rhino is also popular in jewelry, popular in from as tiny tolerances as jewelry, and as high tolerances as you know, cars and airplanes. And you know, the surface modeling modeling ability is superb because of using the NURBS representation of surfaces. So this is just some of the kind of general things about the modeling part of what kind of geometry can be created, and you know, what is the general feel of the application. But I probably, for you who are, if you are a beginner and never used Rhino, I went, you know, very, very fast. So what I'm gonna do, I'm just gonna you know, I'll take a question or two, and after that, I'm just gonna step back and just go really slow, explaining the modeling environment, explaining the main vocabulary that Rhino uses, and you know, we'll take it from there. But if there is a question here, I'm happy to take. Does that kind of give a wrap up of, you know, why Rhino and how Rhino, and you know, when and why to use Rhino is as important as how to use Rhino. So choose your 3D modeling environment carefully and do it in a way that kind of serve your purpose, right? Oh, yeah.
Yeah.
Ufi. Okay, great. Yep. All right, so I'll just close now and not save. And what I'll do next is go through the modeling, what I call it modeling vocabulary. The modeling vocabulary is something that is used by all 3D modeling software, basically. Every single modeling software you will encounter, you will see that it has a way with dealing with all these different concepts. All modeling you know, software will have certain kind of workspace or organization. So let's see what that looks like in Rhino. I'll just basically go through the vocabulary and see how Rhino represented those different things. And the workspace in Rhino is when you first open Rhino, what you see is, you know, the main graphic space where the geometry is shown. So you can think of each one of these four is like a camera or a paper that give you a certain view of your model. I'll just create a small bar, you know, one thing, a box, so that you can just see what I mean. This is the top view of the box. This is the front view of my box, and this is the side view. I'll just, you don't have to know how to do that, but I'll just you know, change the color so it's easier to kind of see what that, and I'll do shaded, maybe more ghosted view. All right. So just so that we can orient ourselves, you can see that in the right view, and the red face is here, and I'm facing the red face in the front, and that's the top view, and this is a perspective view. And you know, the projection here is perspective projection, while the top, front, and right are orthogonal or parallel projection. And you know, this is how it's laid out. It's by no means fixed. It's something you can change and switch between different parts using the lower tab. So if I double click on perspective, the title, you'll see that there is here at the lower part, there is perspective, top, front, right. You can just toggle between them. Double click again, you will go to the 4 view. You can always change the sizes of your views. You can create a floating view, but you can always go back to your 4 views using that icon, which is basically, you know, the 4 views. So this is the main area. This is the graphic area. This is where your geometry is going to sit, and you're going to be able to see it. You're going to be able to kind of view it and zoom or rotate around it. And I'll explain how to do all of these things. But so this is the main real estate that will occupy most of your screen. To the side here, you will see what we call panels, right? The panels are things that will give you information about your workspace. So we have the layers, the properties, but if you right-click on that area, or if you go to the panel menu on top, you can open and access much more than just these two panels, which is the layer and the properties. So for example, I can right mouse click and click on help, which is extremely useful. It will take me to the help, Rhino help, but let me see here. What I wanted is really to go and just the checkbox. And it is taking me again there. Let's go to panel and help. And that opens the help panel. I can click on it. Don't click on the title part, click on the help, and you can dock it and add that context help. And the help is so tremendous because it really have links to all the basics, Rhino basics, but also if it auto updates, if you type box to invoke the box command, it really updates to show you details about the box command and sometimes small videos to be able to see what it is. So accessing help is an important part because even I wouldn't know a fraction of the commands supported by Rhino. So so having help is very useful to have here. As I mentioned, this area is what we call the panels, and each workspace obviously have the title and which version of Rhino up here. Let me bring in this. You will see this image here that really explains each part of the workspace and what it is, and there is a definition of each part under here, right? And I just don't want to overwhelm you with all of that. To start with, it's just in a nutshell, there are all the menus on the top. There is the command area here, which is pretty important. I'll explain that. We will use that quite a bit. And there are the toolbars here. So the toolbars is where you access all the commands basically using the icons. And toolbars also have the ability to kind of expand with extra kind of tools as well. The bottom area is basically all about modeling aid, which what we call the, how you snap to geometry, how you, select certain kind of geometry, and also give you information about your location in space. So that's, down here, there is some information. It tells you about the units you are using, which layer is active right now, and all of these modeling aids, we're going to go over those as well as we go. So that's, basically all the kind of different areas that you see. The thing about Rhino is that, everything is kind of customizable. You can just pull and push things around depending on what you need. You can take things out. And, if I don't want any of that, I can just uncheck everything. And then the whole panel disappears if I don't use panels. You can even just take all the tools or the sidebar away or put it back or relocate it. You can, take that, top menu as well, and, you relocate it or dock it in a different kind of space. And you know, all that is kind of doable, and to be able to customize your work environment. It's meant so that it responds to what you know, what you like to do, and you know, how it works basically. So in terms of the general interface, as I mentioned, there is, you know, this top area, which is the title. There is the menu, which has all the different functionality of Rhino. And basically, it's grouped logically by, you know, all the functionality related to curves, for example, surfaces, solids, right there. And, you know, if you prefer to access toolbars, these are provided as well. And there is the modeling aid down there, and there are the main areas for viewing. So is that kind of clear, or is it, you know, I know it's kind of overwhelming if you're opening it for the first time, but as soon as we get situated, I think it's kind of going to make it easier for us to do things. One of the important things that you get started with is the mouse functions. So if you click on something, you can select it. So I clicked on that and selected it. You see that little widget? It shows if you have down there the gumball turned on or off. So if it's turned on, you're going to see the gumball. If it's turned off, you will not see the gumball. I just turned it off right now. And so if I click on something, I select it. If I hold Shift, I can select other things. And once things are selected, you can drag them, for example, or do all sorts of things. But this is one of the kind of, you know, the uses of the mouse. The left mouse click is to select objects. If you want to pan a view, so you need to hold the right mouse and just keep it down and move your mouse, and that pans your parallel view. Remember, this is how to pan in parallel view only. These are the 4 views here. And if you hold just the right mouse and move it, it will orbit in the perspective view. And this is how you orbit. If you need to pan in the perspective view, you need to hold Shift as well. So that is what it is. In terms of like mouse, if you have a wheel, you can use the wheel to zoom in and out, as you can see, right? And that applies at any of the views. Okay. What are some of the things? Sometimes you kind of move things off the screen, and you know, you don't know how to come back. Is basically this icon, which is zoom extent. It does situate things in the center of your viewport, but if you right mouse click on it, it's actually going to center everything else. So this is just easy ways to get there. The thing about Rhino, it has multiple ways of accessing the commands. But what are the commands? The commands basically are the actions or the functions that are to perform certain kind of operation, whether it's to create geometry, edit geometry, it's view related, rendering related, anything you want to invoke or communicate with the software is done through what we call commands. And Rhino provides four or five different ways to invoke same commands. And the reason behind it is that because of, you know, user preference and productivity. So for example, you saw that we created a box. Let me Control A to select everything and delete. And I am going to create a box now in a few different ways. So The first way is to create it through the menu. And you can quickly guess that a box is a solid. And there at the first top, there is box and different ways to create that box. So I'll just go from corner to corner with height. And that's how I'm creating my box here. I click on it. And then what happens is you need to notice this area. It's pretty important, which is the command area. It gives you instructions about what you need to do. And then you can go with the flow of the command. So for example, it says first corner of base. So we know that we're going to create the base of the box first. And the first corner is what it's asking me to do. The things that are to the right of it are basically the options, the command options. If I want to create the base different way, which is, I start with the center of it, or, with the 3 points, then I can start clicking on these options to create the box in a different way. For now, I'm not going to be very picky. Remember, even if you're in the middle of a command, you can right mouse click and pan your view if you need to give yourself a space. And then just because I have, the grid snap down there is clicked, this is why I can snap to the intersections of these grids. If I unclick it, I can put my point anywhere in space. It's a good practice to click on the grid snap and set up your grid, and we'll show ways to do that so that it's kind of in a way that is reasonable for your use. So I'm just going to go right to the intersection of this X and Y axis, and then click a point, and then drag right up to here, any point really, and that will draw the base. And the next step is to do the height. And you can do that by dragging the mouse on the top view, but it's actually much better if you go to your right or front view or even the perspective to see where the box is. We're going to talk about how to control the location of your geometry. If you want to have a precise dimensions to it, we'll get to all of that. But for now, just click anywhere and then your box is created. You can orbit around it to see it, but you also can change, how you see it. There's wireframe, shaded, rendered. Right now, I'm using the ghosted mode so I can see the other dimension as well. So you can set it to ghosted as well if you want to see it the same way I do. And, I can zoom in by doing the wheel. If you don't have a wheel, you can also hold the control key and then the right mouse to zoom in and out of your, scene, right? So I created a box using the solid menu, drop down, and then selected this command, which is box command using corner to corner and height. All right, so let's do it again, and I see if you can do it yourselves. And this time, let's just try to use something different, which is box using the maybe the center of the base and a corner and a height. So I'm going to call that command, also go at the origin of my coordinate system, drag it, and you see how it is now. Using that center as the center of your box, you drag it out and then create your box. All right. So any questions about how to create a box using using the menu right now? Should be straightforward. Now another way to do it, and I'll just select and click delete in the keyboard, or I can type delete and it does it. And that brings us to the second way to create commands. And to invoke commands, and this is probably one of the most popular, that's almost exclusively what I use. I just drag this window a little bit down so that I can show you the command area a little more clearly. This box where there is the cursor, this is where the command prompt area, and what's on top is the history, which is what is happening right now. It's going to be showing all there. I can type in box, I type B, and if you notice, all the commands that start with letter B autocomplete. So I can go B, O, X, and this is the box command right there. And then any command that has the word box or close, BO or things, it will list here. And this is really easy way to quickly type, whatever command, especially after you become familiar about the set of commands you typically use. So I click on box, and box command basically starts. And let's use one of the options. So I click on center, and now it's asking me for the center of the base. I click point, drag it out to other corner or length. That means I can enter, say 5, and that is saying I am restricting myself to 5 units along the x-axis. But I can also do 5, 5, which means I am basically going to go 5 units in the x direction and 5 units in the y direction. And that helps me be a bit more precise. Or I can interactively drag and click on the base. And then if you notice in the command prompt, it shows the word height. Or you can basically specify the height. You can say 10 units. And then if you press enter, then it's going to create a 10-unit height, right? Now, if I want to double check that the height is 10 units distance, I can type distance, and that brings up the distance command. And then it asks me for the first point, and then the second point, and it gives me back the number of units. And as you can see, I'm using millimeters in my workspace. An important thing, if you don't have your O snaps turned on, you might not be able to go select exactly that corner. And it's really useful to have the O snap turned on. And once you turn on the O snap, which is this dialog, it's usually docked down there. You can say, I want to snap to certain parts of my geometry. I usually want to snap to all geometry, the end, near a geometry, a point, a midpoint, a center, a perpendicular, tangent, quad, knot and vertices are basically for more to do with meshes. But now I can just grab the top and dock it back down here. All right. So this is where the snaps, where I can snap, and this is why when I ran the distance command, distance again, press enter. When it says the first point, I was able to kind of, when I come near, let me maximize that. When I come near the corner point, it just basically snaps to it. So I can use that as my first point, and then it snaps to the top point as well. That's the second point. And now I can really measure the distance there, right? So this is where what the OSNAP is really about. And this is what we call a modeling aid. Everything down there is really helpful as a modeling aid. And one of the parts is the OSNAP. It's really, really helpful. All right. We can go and explain other ones as we go, as it becomes necessary. So that's the second way of creating, invoking a command. we use solid box from the drop-down menu to create a box. We're able to type box here and create it in our scene. Now, you can also create boxes using the toolbars. And as you can see here, the standard toolbar here on the left, if you go through these tabs, you'll see different icons appear on top, but also, you know, curve tools, for example, when I click on it, the left sidebar changed to include some more commands related to curves. If I click on surface, it's just gonna show more surface command. If I create solid, it's gonna show more of the solid commands. And the standard has all the common ones that are widely used, basically. And over time, you're gonna be able to kind of recognize all the different kind of icons, and if this is the way that you are most productive, then you're going to start relying on the icons or the toolbars. So in order to be able to access you know, the box command, I can go to the solid tools and then there I can see the box icon there. It's very easy to spot the kind of geometry you want to create from the shape of the icon itself. And if you hover over it, it's going to give you two things. It's going to give you the name of the command, but also it's going to show you which part of the mouse you need to click in order to be able to access the command. What you also see is that little triangle at the bottom, which is the cascade, which is other commands to create a box. If you click on it, it just show you a fly out, and that will have, you know, the box from a corner to corner or diagonal or 3 points, or, you know, using certain, well, that's creating a bounding box is different. But if you click on the main one, it just what it did, if you look up there in the command history area, it just also have the box. It basically called the box command. And now we're going through the process again to pick a corner point, second corner point, and our box, right? So these are some of the kind of main ways, 3 ways to create, you know, or invoke commands in Rhino using the menus, the command line, and also the toolbars. There are other ways to create things in Rhino, which is, you know, interactively. And let me just go over how to do that. And one of the ways is to use the gumball. See at the bottom here, if you click on gumball, then whenever you select a geometry, it's going to show that widget. And I'll explain that in some detail, but I just going to show you something, some of the functions that a gumball help you do. For example, move geometry. Although you can move geometry using the move command as well, and you go through the process of reading select objects to move. I select my object, press enter, and then it asks me from what point to what point, and then I move my, my object. But if you have the gumball open, once you click on it, that widget has all these arrows that point you to in which direction you can move your geometry, and you can move your geometry. There are other things you can do in these widgets, which is, you know, to rotate. If you click on the rotation part, you can rotate in any direction. And then also you can scale in one direction, and with shift down, you can scale in uniformly. So all these are available as commands through the drop-down. For example, transform menu has the move command, and also the standard menu has the move command right here. So the same command can be called in different ways. You can type the name move. And eventually with time, you're gonna create the set or the workflow you're most comfortable with. I find typing the command names to work, you know, the best. And then I don't have to remember which toolbar, which menu they exist. And it's just really faster way to access your commands. So this thing is what is the, you know, the filter. If you click on the filter, it's going to show you the selection filter. This is what it is. It's the selection filter. And if you click on the word filter towards the end to the right, if you can see it, it's just going to either turn it on or off. Can you get that?
Yeah, that did the trick.
That did the trick. And what the selection filter is actually limit what kind of geometry we can select. Right now we created solid, so what we call it in Rhino poly surfaces. So I can click on a poly surface and I'd be able to click on it and drag it. But if I uncheck poly surfaces, I will not be able to select any of my boxes anymore. Right? And this is pretty helpful if you have a scene that has, I'll just create a circle by typing CIR and it auto completes up there. So I'm creating a circle here and I have a mix of curves and surfaces and poly surfaces and meshes in my scene. And it's hard to, I just want to select one of the curves. And you know, one way is just uncheck the other geometry, and now I'm able to select only the curve. I'm not going to be able to select the poly surfaces. One way to select as well is to click somewhere on your scene and drag a window. So that's a window selection. And now you can see that I wasn't able to select any of the boxes, but I was able to select my circle here. Right? So the selection filter is really useful to help you select certain kind of geometry over another, especially when you have a crowded scene. I'll just check it and I'm gonna drag it back down there. And once you see this purple thing, you just let go of your mouse and then it will dock it down there. Okay. There are obviously other modeling aids, for example, the ortho. The ortho will limit your ability to move your circle on, you know, only in the orthogonal kind of directions, you know, along the y-axis or the x-axis. And this, you know, just keep in mind, Rhino is super customizable. So even the direction of the ortho, I can change it to 45 degrees or, you know, every 10 degrees. So that will make me, you know, be able to move things in certain directions, not just, you know, the X and Y direction. But for now, we're just going with the super defaults of the Rhino as you open it. And then with time, as we become more proficient and comfortable with the environment, we can start customizing completely the looks, the feel, the set of tools. We can even, let me just give you a sneak peek. If you click on the wheel, it will show what is called the pop-up menu, which is some of the common toolbars or tools that is used. And you can totally customize that. You can, if you use a lot of boxes, you can basically, with the control down, you can drag a box and just drop it here. And then now, if I'm a kind of person that create lots of boxes, I click on the wheel and click on my box and the box is right there. You don't have to kind of repeat that, but I just want to show you that the extent of customizability of Rhino is the ability to create your own pop-up icons. If you right mouse click and keep it right, then you have another kind of pop-up, which is, you know, show you the latest command, but you can also add set of commands that you like and use a lot to that menu. I don't mean to throw you off, but just to say that, you know, productivity is a big part of Rhino users, and it's super customizable and very easily so. So that's, you know, that's part of what you can do. So the ortho, you can turn it on or off. The planar basically is going to restrict you to work within certain plane, to draw within that plane. So that's the planar. Record history is an advanced kind of functionality that we'll get to later. And the filter, we've just done it, turn it on and off. And this is basically, other than that, there is also the grid snap. The grid snap allow you to snap to your grid. The spacing of the grid, how to set it up, we're going to show you all that, but also you can customize that part. If you right mouse click on the grid snap, is just going to show a small menu to turn it on and off, but also to be able to turn it off in a specific viewport or all viewports. So I can turn the grid snap off here, but if you go active viewport, you can also like show or hide the grid lines if you wish to do that. And if you wanted to be across all viewports, then you can just you know, turn off the grid axis in all my views. And you can see that all the views now, they don't have their axes. So right click, all viewports, show the grid lines, all viewports, show my grid axes. So that's basically, you know, general overview of the Rhino environment. I think the only thing that usually is shown is the layers, and you can duck the layers anywhere you like, you know, to the right, to the left, and be able to draw within certain layers or organize your geometry there. But that we'll get to it as well at some point. Any other questions? Yeah, were you able to kind of catch up? Is that clear, or is it a bit overwhelming? I want to hear from the ones that the users or the students who haven't used Rhino before. Are you able to kind of follow? Yeah, 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 yeah. Thank you. So I think it's kind of useful to talk a little bit about the panels, since we just opened the panels and what they are for. The layer is obviously one of the essential panels that you will find yourself working with a lot. Basically, anything I have created is created within the active panel. I'll just expand some of these so that we can see the details of what's in the panel, what's in the layer panel. Here, everything, that's everything. All right. So as you can see, the layer panel has some tools up there to create a new layer or, you know, do certain kind of functions. But what's important is in the active area, which if you click on this and click again, you can change the name of it. And this is your main layer. Rhino opens with at least one layer, and it's usually has the name default. And it default to the color black, but you can change that color. Click on it, you show the wheel, you can have any color for your layer. Typically, the color of the layer is the color of the object. So by default, all objects take the color of their layer, unless you specifically specify different color for your object, and I'll show you how to do that. This checkbox, this check shows that this is the current layer I'm on, and you can lock the color, the layer, but not the active layer. You can change the material, and the material is only relevant if you are in rendered mode. So right now you can see the default white material, but I can change that if you click on it, and be able, I'll do something really basic. I'll just change the color to something different, like a 10. And oh, that didn't create anything. So it's using the default material, and I'm going to change it to a different material. Say I want to use a plaster material, and I want the color to be the tan color. And okay, and that basically changed the material here to plaster. And if I go back to my kind of shaded mode, everything is disappearing, because what's relevant here is the color of the layer. This is a working kind of mode, but the material, you can apply different materials and transparency and gloss and reflection and all that, but that's relevant to the rendered. And you can see the material applied to that layer is right there. The line type is, you know, relevant to curves. And if you click on it, you can change it to dashed, and you can see that my circle now, let's go back to wireframe. My circle is using that border kind of color, you know, line type. Yeah, I can change it to dashed. The scale of it can be changed and all that, but I just wanted to show you the different kind of things. Usually go back to the default, which is the continuous, and that's basically what are the different parts of the layer. You can create a new layer by clicking on the icon, new layer, and that generates a layer, and by default it's called layer 1. Again, I can change the color of it. I can now turn it on or off, because it's not the default color layer. I can lock it, which means I can't really select any of the objects created inside it. And again, I can change its material and line type. In order to make it my default layer, I just need to put the checkbox in there. So under the current, click there, and layer 1 became the default. That means any geometry that I create, say a box, see how it's a black? And it's actually generated inside a layer 1. If I turn layer default to on or off, all the objects there will be turned off. If I lock it, I cannot select the objects that are in that particular layer. So it's really great way to organize your work. It's not unlike any of other modeling software, where you actually, many people actually put you know, all their parts, you know, the window parts or the elevation or certain material, wooden material or whatever, in separate layer, and apply material by layer, for example. Or they want to export certain parts or turn it on or off, you know, your 2D drawings, your scaffolding. You all can organize it by that layer. You can see that the icon next to the new layer is the sublayer. This is where you actually can create a sublayer. And think about the sublayer, you can you know, turn them on and off all together, and you can tuck more under your main layer this way. Layers are extremely useful organizational tool, and it's used like any other application, really, CAD application. So if you've used any other application, Photoshop, anything, you still can use that. Here, there is also other things related to print. You know how you like to show it in a print, if you have like different setting for print setup, if you have a print width that is different. So you can set up your layers to be any kind of combination of settings. Now the other panel that is very important, and I'll right mouse click here on the header, and it is the properties panel. The properties, and I'm just gonna drag it out here and grab it by the top and tuck it under under the layers. All right, because many times I find myself want to see both the layers and the properties. The properties are something that context sensitive. So I'm clicking on my perspective and it's showing me the viewport properties. It's telling me you are in perspective and this is the lens length, you know, and this is your camera setting and what have you. This is all, oops. I just grabbed it and put it sideways before, without noticing. So basically, this is all the information related to my camera and you know, the different other information related to my viewport, right? If you actually select on an object, then the properties update. And as you can see, it shows me things specific about the object. For example, which layer is it in? And then actually I can move it to different other layers. I say, oh, I actually want to move it to layer 2. Let me change the color of it so it's kind of a little bit more recognizable. So I can say, okay, that object, I want to move it to layer 2. I want the display color to be, you know, by layer or its specific thing. I can even, you know, change, if you go through these icons on top, I can change the material of that particular object. So I say, okay, I'm going to apply specific material. Maybe I'll apply the plaster there to my object. And once I do rendered, you'll see that despite that it's in a different layer, which is layer 2, and it has specific material, the object material that I assigned is applied here. So these are all related to the objects themselves. You know, you click on an object and it shows you information about the object itself. If you click on details down there, it will really tell you a description about the object, what kind of object type it is. You know, is the geometry valid? And this information we will learn how to read and understand with time, you know. But this is basically stat or information about your object itself. In a programming language, we say attributes. And attributes about an object is information related to that object. So each object in Rhino has two parts, which is the geometry itself and the attributes. So properties help us set up the attributes of different objects or give us information about viewports or anything that happened to be active at the time, you know, we're you know, at any point of our modeling. So that's what these are the two panels that are extremely important. As I mentioned, you can also access the panels from here. And you can see that, you know, you can have notes. Display is also a commonly used panel for people. The help, I'd say, is very important. If you're doing rendering, you might want these panels to be open handy. You know, and we're gonna use some of those as well as we go along. But I recommend that you have the help as well. If you click on the title here, you can tuck it with the layers, and you know, you can tuck the properties up there as well. I'll move the help to the right. Oops, here. And then you can use the help to access any of the commands. You can type box, enter, and then it will show you the box command. So if you want to inquire about certain commands, this is a great way to quickly reference the information. Any questions related to panels here? We have half an hour, so I will continue to loosely go through a few concepts that I find to be extremely important in any modeling environment. And I'll let you review the document between now and next week. And we can start by you know, going over any questions you have. the two topics that I think are very, very important and relevant for us as architects are the coordinate system and geometry. So let me just delete those. And if we are not interactive and questions and answers, I think it's going to feel a little bit heavy of me talking too much. So anytime you kind of want to break the rhythm or redo certain things or inquire about certain things, please feel free to kind of jump in. And as I mentioned, the beginning is a little hard and overwhelming, but with time, and if you review the document and go through some of the video tutorials there, and if there's anything missing, just comment on it or shoot me an email. And then we're going to make it as whole, as complete as possible as a reference for you. I understand you can't get everything down today, but I'm just trying to kind of give you the general feel and the important components of the modeling environment. And we're going to go straight to starting to create our house from next session. All right. Okay, so let me see what we can cover here is in the remaining areas as an overview is the coordinate system. The coordinate system that is used by Rhino is the Cartesian coordinate system, which is the used by most modeling software, but it uses the left-hand side coordinate system, where the middle finger is pointing to the x-axis. The pointer is pointing to the y-axis, and my thumb is pointing to the z-axis. All right. So if you look at the viewport in Rhino, you'll see. I'll just draw a line here. Where's my grid snap? Just to emphasize my x-axis here, I'll do arrowhead. And as you can see here, that this is the direction of the x-axis, and I'm just trying to create markers here just so that you can see where the x-axis is going. This is the x-axis, which is the red one, and the green one is actually the y-axis. That's the y-axis. I'm going to change the color of it. Go to property. Instead of by layer, I'm just going to click green. And now my dot is green. I'll just use Gumbo. Well, I'll just rotate this. And change the color. Oh, I needed to rotate with copy. And I'm just I'm gonna just generate some geometry here so that you can basically see the x-axis and the y-axis. And you can see that little widget here down the bottom that show you the direction of the X, Y, and Z. So the Z is going in that direction, and I'm going to do a vertical line starting from here and going up, and arrowhead. And this is my Z-axis. I'll change the color to blue. So as you can see that this is the X, Y, and Z, and I'm using the right mouse down and I'm able to orbit to change the direction. So you can see that we all deal in computers with screen, but in Rhino we are 3D modeling in real space, and we try to use units that is full scale of our model. So if you are, you can use meters, centimeters, millimeters, any kind of, but you model your objects in a true dimension, basically world dimension. And this coordinate system that we have here, we call it the world coordinate. And basically, this is the origin, which is 0, 0, 0, and it has the X, Y, and Z directions. Every viewport in Rhino, which is the active graphic space, has what we call construction plane. The construction plane is where, if I say, I'll type polyline. If I want to draw a polyline, by default, it draw it within my construction plane, right? So the construction plane on Rhino in the 4 views, and let me just take that down there. In the perspective, it actually defaults to the top view, to the top world view, basically. That's where it's located. And if I double click on my views, you can see that this is the top view. That's the plane is the same. The construction plane is the same as the one that is in the perspective view. But in the front view and in the right view, the construction plane is a different kind of location. So if I draw a polyline, again, on the front view, as you can see, it is actually creating it in the XZ direction. As you can see down the bottom here, is say XZ. This is the construction plane. By default, you will draw on that plane, right? And this is why having multiple views is useful. Now, if I draw polyline again, by the way, you can run the command again by either pressing Enter as a shortcut or right-click on the command prompt area and go to the most recent command that you run. So that's polyline. And if I draw here, as you can see, it's actually drawing on the YZ plane, right? So basically, Rhino allow you to define your own, construction planes and where they are located, and be able to draw only within that plane, unless you are snapping to certain geometry, unless you are typing exactly the location that you want to create an object within. And let's see what that means. So let me just delete those. What I'm going to do, I'm going to select all these, and I'm going to say lock command. And this will help lock these objects so they don't become selectable, but I just need them for reference right there. Now, with Rhino, you can, do precision kind of modeling. What do I mean by that? Say, for example, if we want to create a line, L-I-N-E, up there, the start of the line, you can either snap to a point, but you can type the coordinate of where you want your point to sit. And you can say, I want it to be 5, 5, 0. If you have used AutoCAD before, you probably are familiar with that notation. So you can type the exact coordinate, and then next I can say, actually, the next point I want it vertically by 5 points. So I can go 5, 5, 5. And now you see I'm not confined to my construction plane because I specified a second point that is in the vertical direction, which has a world coordinate that is 5, 5, 5. All right. So this is what we call typing the coordinate directly. I have in the handout really nice table here for you to reference. Let me go down to coordinate system, this one. This one has examples of how you type. You can, you know, the numbers you type or the coordinates, sorry, you type X, Y, Z is relative to your construction plane. So if you are in perspective or top, that's going to be X, Y, Z relative to your construction plane. And so this is, you can type the coordinates straight away. If you want to strictly have it a world coordinate, you just need to type W in front of the coordinate, basically. W0 means W000. There are a couple other ways to, you know, type coordinates, which is polar or relative coordinates, where you can use distance and angle, right? And say relative to my last point that I created, I want 17 unit in the 45 you know, degrees angle. And the relative coordinates is also very helpful to you know, draw or specify a location relative to the last point that you used. And you just need to put at or are at the beginning of the coordinate. You can get used to that notation. You can use it, or you can totally skip it if you have reference geometry to snap with too. But this is really useful to, if you want to go precisely to certain locations, to use that relative coordinate notation. So along with the construction plane, I'll explain a little bit further about it, and I'll leave you with trying to do that exercise. And if we have the time, I'll go over how to do it using the coordinate notation and the construction plane. And I guess that's pretty much all the time we have left, and I'll leave you all to just explore the rest of the modeling aid. And as we go through the other chapters starting next week, we can go back and revisit certain concepts if they are not very clear. All right. So now that we know or we understand how the coordinate you know, system is in Rhino, I'm just gonna do something here so that just to make it a little bit clear as to when you type the coordinates, how it works. Now, if I'm in the front of you and I want a point that is, so let me go and say line, and make sure you are inside the front, right? And I'll keep the perspective so we can see. If I type 5, like I did in perspective, the point is actually going to be relative, as you can see here, to my XZ plane, because I was in the front and I wanted to go 5, 5. So relative to this particular construction plane. And but if I want to end up in the exact location here, I can snap to it, but I can also type the endpoint to be W, which is relative to world coordinate 5, 5, 5, just to ensure that I end up right here meeting that other point that we created right there. So just be mindful that when you type the coordinate, be mindful of which construction plane you're in. If you are in the top of perspective, that will be relative to the world XY plane, and the numbers, you know, you don't have to type W in the front of it, and you'll land where you expect it to. If you are in a random construction plane or in front or right, then just be mindful and you type the coordinates relative to that construction plane. Now, construction planes can be set up to be at any kind of location. So for example, we just created these 2 lines, and suppose I want to draw a circle within that plane, within the plane of these 2 red lines that I just created. it is actually pretty hard to draw, say, as if I say circle, and just to snap to that point, is going to by default be restricted to be parallel to my construction plane. So it will go in that direction if I'm perspective or top, and if I'm in the front, okay. Let me just do that. I'll run circle command again, and I'm snapping to the intersection of the two red lines. And now if I'm in the perspective, it's going to go in that direction, parallel to my XY plane, as you can see here. And if I go to the front, as you can see here, it's going to be parallel to my XZ plane. And if I'm here in the right plane, it's actually going to be parallel to my, YZ plane, right? And in this case, that's probably where I want the circle to be, so I can just create the circle to be within those. But what if this, is in a random kind of, let me just select both of them. And I'm just rotating. What if my plane, my reference plane, is just somewhere random in space here? I created a pyramid, and I actually want to draw a circle on one of the slanted kind of faces of the pyramid. Why don't we do that? I'll just delete this, and I'll just say pyramid, and I'm just gonna create it to be a three-sided pyramid, change the option here, and that's my pyramid. Let's go to perspective. And as you can see here with my pyramid, I want, say, to draw a circle on that particular face. Let me explode this, and we'll go through geometry in a little bit, but I just want to change the color of that face. Going to property, the display color, I'm going to make it green, just so that I can differentiate that face, that particular face I want to draw a circle on. In Rhino, it's pretty hard to draw on that slanted face unless your construction plane is oriented in that direction. The way to do that is really pretty straightforward. You call cplane command. And cplane command has many options to orient to certain things. Say if I want to orient to a surface, I click on the surface option and click on my surface. And it just gonna ask me like where I want my origin to be. So I can just drag the origin to the base of my pyramid. And this is my X. And as you can see, my grid now was reoriented to be along that face. And as you can see that, the grid and the XY and everything has been changed to accommodate that. The locked coordinates are the world coordinates, but the new construction plane is right there now. Now, if I draw a circle, it's pretty straightforward to just go anywhere here and draw, and then it's gonna land right onto my construction plane. Right? Sometimes, and we will do that in our house because it's going to be somewhere in space and oriented somewhere, we might need to generate certain construction planes. And it's quite useful to actually save the construction planes that you actually use in your model. I'll click on this wheel and go named C-plane. By default in that panel, you'll see the world top, the world front, and the world right. So if I double click, now that I changed my construction plane in this view, I can double click on world top and I just go back to my world coordinate or my C-plane, world XY C-plane. If I want, let's run the command C-plane again. and I'll just use it 3 points this time. That base and the other and the top. So I changed my C-plane to be the green C-plane. And what I can do is basically I can save it. And I just click on the icon, save as, and I'm just gonna call it a green. Okay. So now anytime I'm world top in my perspective, I can just double click on a green and go right back to work on that mode or on that construction plane. And then when I'm done, I just can go back to my top plane. Working with construction planes is sometimes confusing, but once you have a workflow where you actually save some of the main construction planes that are useful to your model space, you will find yourself, working really easily. Along with the snapping and modeling aid, you'll be able to orient or why don't you just do a quick exercise now? Create a box. And let me delete this. Create a box and change its orientation using gumball, which is rotate along a couple axes. Explode your box so that you have all the different surfaces of your box. Select one of them and then go to layers, go to properties and change the color of it to something different like cyan. And I'd like you to orient your C-plane to land on that cyan so that this is the origin down here at this corner, and this will be the X and this will be the Y direction. Once you do that, I'd like you to draw a couple circles within that plane. Just a quick exercise, and I will silently go through it if you feel like you need a reference point, just so that to check that you're comfortable with generating construction planes. This is a pretty important step.
I don't understand how to get the axis lines like on like the same line as the surface.
So what we want here is to create the X axis along the bottom here line and the Y along that line.
Yeah.
All right, so that's the objective. And the way to do it is you just call the C-plane command. Once you are in the C-plane command, it will really ask you if it has multiple options. The all is basically if you want to update all 4 viewports to follow that new arrangement, or so that's the yes and no. And the curve is if you want to use a reference geometry that is a curve, or I use gumball or a certain object, or just rotate your current plane, or there are different ways, or go back to world. In this case, just because we are using that plane, you can go with either the surface and then select that top surface, or 3 points. 3 points is really nice here because you can immediately select the origin, the x-axis, and the y-axis. So I'll just go through and select point, and then it will ask me where is the C-plane origin. I'll just go down to this point, and then it will ask me the x-axis. See, this prompt is really important. X-axis, I'll just snap to that end. Make sure that your snaps here down in the modeling aid at the end and point are all activated. So you can snap to the end here, corner, and then the Y will go there. And then I have just created a C-plane that is aligned with that face. Does that make sense?
Yeah, no, that was perfect.
Yep. The next
and then
step.
Save it.
Save it, exactly. So I'll save it and I'll call it blue. And now blue is here. Even if I'm different seaplane, I can quickly just go back to blue. And now if I just draw anything, let's go cylinder. It will be by default, relative to that particular seaplane. Right?
Did you create a saved seaplanes panel?
The panel here, it's named seaplanes.
Oh,
So if you go on this
setting
gear, and then you just check the name seaplane, and it will be added to the tabbed panels there.
I see.
Another way to access it from the panels there and named seaplane.
Mm-hmm.
Yep. So once you have your seaplanes handy, you can start switching seaplanes, and you can quickly orient yourself. So if you have an elevation, for example, in your model, or a roof, or you create these seaplanes and give them meaningful names. And then if you need to draw anything relative to those surfaces, you can quickly invoke that seaplane and draw. Makes sense? And then even accurate modeling works. So if I just say, now that I'm in that seaplane, if I say, for example, line, and if I go, I want to from the origin of my seaplane, it's actually going to start from the origin of my blue seaplane. And if I want to go vertical to it, I can go 0, 0, 10. And it created a line relative to my seaplane and in these directions. So all the coordinates that are entered are relative to the current active seaplane. Everything starts to work. Any questions about seaplanes? Yeah, we're good. So yeah, this is considered one of the more complex or confusing concepts in modeling with Rhino. If you get the seaplanes down, your modeling is super easy. Many people use seaplanes or use scaffolding. So if it's easier for you to snap to certain geometry, you can use a scaffolding instead. And this way you can just snap to that geometry, and the orientation sometimes tricky, but you can manage to do that. The easiest way, if you know how to deal with construction planes, and the modeling become very, very easy.
I'm just curious,
Yeah,
a different color.
Say that again, Zane.
Why is that surface of your box a cyan color with the rest of it's red?
Because I exploded it just so that it's kind of easier. I can go by layer back. I selected that surface, and I basically changed in the properties what color it is, just so that we can see it more easily. That's all.
Oh, thanks.
Yeah. There isn't any like hidden purpose there, but yeah. Just for clarity. So if you're comfortable with doing the accurate modeling here, and see, you should be able to do that exercise. I guess it's a take-home exercise where you can generate a random, twisted kind of seaplane, and then you try to create that polyline. And there is a full instruction as to how to, what is the requirement of it, whether it's relative to the custom seaplane or it's relative to the world coordinates. And just using this notation, you'll be able to kind of start to create that. I'll do it first thing in our next meeting, but I just want to give you a chance to generate that. This is a really excellent video as well. So all the resources, all the videos there is for you to just go and review. If you have time, I will quickly go through that a very important concept, and maybe we'll leave it for next time, because geometry is a huge part. This is an advanced concept. We'll do it tomorrow together. But geometry is a very important part of how Rhino works, and specifically NURBS geometry. And you know, how you create the geometry, how do you specify it, how you modify it, how you connect a different geometry or join, and also, you know, the surfaces and NURBS surfaces, and the concept of the surface degree and trimmed surfaces. All these are very important concepts. And then you go with the solid geometry and the what we call the poly surfaces. Rhino supports other type of geometry, which is extrusion and you know, the mesh geometry. However, Rhino 7, there is yet another geometry type, which is the subdivided surfaces. It's really powerful for organic kind of modeling. And then there are topics about how you can transition from one geometry type to the next. We covered the layers. So I think maybe 5 minutes, I'll just create these different kinds of geometry, and I'll leave it up to you guys, because we're hitting the end of our session, to go and review those. And let's use the first 15 minutes next session to solve the exercise, and then go through any questions you have related to the handout. All right? Sounds good? All right.
Okay, very good. Yeah.
So let me just go back to world coordinate here, and let me just delete this. And we have already done quite a bit of geometry, but the main thing to think about is that all curves are, and the different ways to create curves is under this menu. The drop-down menu is really nice in terms of navigating the different geometry that you can create with Rhino. The freeform and control point based curve is probably the main command that is a lot of people use, which is curve command. You can type curve here and be able to create a NURBS curve. If you look at it, you'll see a very important option here, which is the degree of the curve. What we're gonna do, we're gonna create the same curve using degree 1, degree 2, and degree 3, and compare the different results. I'm just gonna go to the top view here. Let me minimize that. And before running the command, I'll create certain points which will basically represent the control points or the reference points I'm gonna use to create my curve, all right? So starting from the left to right. Now let me run the curve command, and then I'll start with degree 1. Degree 1 NURBS curve will pretty much create what we know as a polyline, which means that the control points or the selection points that I use to generate the curve will line up exactly at the points that I specified here. And you see these sharp edges, you know, which we call kink. This is a curve that has a kink here, which means it's just basically broken here at that point. This is one curve. And if I want to interrogate or understand, I can go to properties under details. It's going to give me all the specifics about my curve. It's going to say, this is an open NURBS curve. This is where it starts. This is where it ends. And the key here is the degree, which is degree 1, right? And then it gives you more details, some of it geeky details about that specific curve. It also gives you at the top here the ID of the curve, which is just basically its name, its code name, unique name. It says that it doesn't have any name. I'll show you how to put names to objects. It's in layer default. It doesn't have any render material, and you know, that's other information related to the curve. So this curve that we just created is degree 1 curve. I will run the curve command again, and this time I'm going to change the degree to 2. All right. I will trace the same points here. And that generated a curve. Let me put it in layer 1, so it's black. And you can see that the curve is a bit more smooth. What degree 2 NURBS curve means is that to generate this part, I'm going to rely on not just 2 points, but 3 points. And I'm creating an approximation or a NURBS curve in between those 3. So these 3 points are going to be the determining points to generate my my curve. I don't want to get too much into the mathematical underlying notation of what NURBS are about. We can get to that later, maybe, but you can see that the curve is much smoother than the one I just created with degree 1. And you can think of like the most common degree 2 curves are circles, for example. They are degree 2 curves, NURBS curves. Now I'll run the command one more time. Let me go to layer 2 and be active inside layer 2. And I'm running curve command again. I'm changing the degree to 3. Degree 3 considered to be what smooth curves are. And I'm going to trace these points again. And you can see that that curve is a bit more smooth. And each segment or part of the curve is now affected by the degree +1 control points, which is 1, 2, 3, 4 points define that portion of the curve. And then the next 4 points define the other portion. And this is how NURBS work. The thing about NURBS curves is that they can be super accurate. So if you go down there, you don't see any of the, if you create a polyline, no matter how accurate or like a small tolerance you use, if you zoom close enough, you're going to start seeing these lines, line segments. But with NURBS curve, you can make an extremely smooth geometry or smooth curve. The other thing about the NURBS geometry is, let me just copy this. So I'll turn on the gumball here, and I'm just going to click on the little arrow here to move it up. But I'm going to click on Alt, and you can see the little plus, which means I want to copy. So I copied this. If you click on it and type points on command, or maybe by default in your case, you can see all these control points, you know, the original points I traced. These control points help me modify my curve. If I move them around, I'm going to be able to modify my curve, as you can see. And it remains extremely smooth curve, but you see how that, what we call control points, can change or help me modify my curve. All right, so that's a NURBS curve. A NURBS surface is basically a network of multiple curves. So you can think of it as being, let me go to perspective here. And I'll just copy that one vertically, Alt. I'll do points on. Points on, and I'll modify it a little bit. And what I'll do is I will create a surface between these two curves. We can go through all the different surface commands, but one of the commands is loft, and lofting is basically you have multiple curves that you want to create a surface to loft in between them. So that's what loft command is. So I'm just selecting my curves, and I'll just go default. And as you can see, a surface was created. I can turn the points on, P on. And as you can see, the control points now are showing. And just like we did with curves, you can start sculpting your surface by moving the control points as well. So that is a NURBS surface. Let me just go to wireframe. And as you can see here, it's like almost made of multiple or a network of curves. The lines you see going through are called isocurves. I can change the density of isocurves here under properties, density 1. I can increase the density to 2 or 3 to be able to see the, so it doesn't change the surface itself, it's just for viewing purposes. The thing about NURBS surfaces is that it's basically the direction of the curve matters, what we call the UV space. This is pretty involved kind of thing to explain towards the end of the session, but I'll leave you with just one thing here. I'll want you to differentiate the different direction of a surface. So this bottom part is considered one direction, and the top, the vertical parts is considered another direction. One of them we call the U direction, and one of them we call the V direction. I'll probably have you review the guide, the manual first, and maybe I'll explain what the NURBS surfaces are as a geometry in the next session. One thing that you can do, options, under options, and now we are really, this is really very powerful setting. Everything you want to set in your document, which is particular to the document you're using, or all documents on Rhino, you can set it up using the options. I'll just go down to the view and display mode and go to the wireframe. And under wireframe, under objects, surfaces, what I will do here is that...
Rajaa, I'm looking at the time. It's 1:10. Some of the students will have class starting.
Okay. So we already passed the time. Okay.
Yeah.
How about we leave that for first thing next time? And I think that's a good point to stop. I guess you just can follow with the manual, and then we can explain these details next time.